Hello, this is Xinru. In this video, we are going to take a look at question 1424, diagonal traverse. This is a question in weekly contest 186, and in this question, we're given a lists of integers, and we have to return all elements of numbers in diagonal order as shown in the below images. So if you look at example 1, so we have to return our result so we have to return the result with the diagonal lines from the top left to the right below side of the image, and and the list of lists we are given is not a matrix. As you can see, this nested list we are given, they are irregulars, and if you look at example 2, you'll see at line 4, from the number 9 to number 4, there are only two numbers, and these two numbers are missing, but we still have to output both 9 and 4. So to solve this question, at first I thought of an algorithm that I go through all those numbers from the boundary. So for example, 147, 7, 8, 9 in example 1, or 1, 6, 8, 9, 12, and 13, 14, 15, 16 in example 2. And then I draw a diagonal line from those numbers, and I keep using a if statement to determine if the next number exists, and then if the number exists, I will push the number into my result array. And it passed 56 cases, but there are 2 cases that that my algorithm couldn't pass because it took too long. So the time complexity is not ideal. Therefore, I looked up at other people's solutions and find out there's a very brilliant solution, and I'm going to introduce it. So the key point of solving this problem is that on every diagonal that I'm going to push to my result array, all those diagonals, they have one thing in common, is that the left number plus the right number, they're always the same. So for example, if you look at the diagonal 6 and 2, you'll see if you look at their indexes, you find out the number 2 is in an index of 0 and 1, and the number 6 is in an index at 1 and 0, and they add up are the same. And if you look at the indexes for 8 and 7 and 3, you'll find 8 is 0 and 2, 2 and 0, and 7 is 1 and 1, and 3 is 0 and 2, and you'll find out all those numbers, all those indexes of those numbers, they have one thing in common is their left index plus the right index are always the same. So we can use this pattern. And how are we going to do that? So first we have to think about in what way we can organize those data so it is very straightforward, and then we can use those data to form our result array. So the answer is we can use a hash map. So at first we go through those we go through every number in this list one by one, and then we put those numbers with the same sum of index together, and we push those numbers into our hash map. So our hash map will look like this. So first there will be the index sum. Sorry, it's not very let me write it in a clear way. So our hash map will look like sum. So this will be our index sum, and then we're going to assign, so the key will be the sum, and the answer will be an array with all the numbers that their indexes adds up to the same number, to the sum. And then what we can do is we can just append those numbers inside the array into our result array in a reverse order, because as you can see in our result array, it's always start from 4 and 2, and if we iterate through our given array, and we make the hash map, our hash map, so the answer in our hash map will be in a different order, so will be a reversed order. Therefore we have to reverse it back, use the reverse function. So now let's get into coding. So first we need to think about some boundary cases, and in this case the boundary case will be if the number we are given doesn't exist, then we will just simply return an empty result array. Then we create our result array, and we need our hash map. Now what we need to do is we need to iterate through the array we are given. So we use a nested for loop to iterate through the array we are given. So during the iteration of the array, what we can do is we have to so we have double indexes, so we create our sum. So we create a variable called sum, and this variable is I plus j, and then we push this variable into our hash map, and if the hash map if the key doesn't exist, then we create a new array and assign it. If the key already exists, we push the new numbers into the existing array. So there's a if statement. If hash map of sum doesn't exist, then hash map of sum will equals to a new array, and this new array has our number, so nums of I and j. And on another case is if the hash map exists, is the array exists, then what we need to do is just push in the new number. Okay, so now we get our hash map, and now what we need to do is use the hash map to create our result array. So what we can do is we can iterate through our hash map every key. So we do a for loop, let key in our hash map, and we iterate through the hash map. The way we iterate through the hash map is that we need to iterate it in a reversed order. So we result dot push the number of our hash map's key, and we reverse it. So we use a spread expression to put the numbers, put the elements inside our array, specific array, and we first reverse the array, then we use the spread expression to put every element into our result, and eventually we return our result. So there's one arrow, hash map push is not a function. Oh yeah, so we need to hash map of sum of push. So as you can see, so the key point which makes it very easy to write the code is that we find out the pattern that in every diagonal their indexes, so the sum of their indexes are the same, and we use this pattern, and we also need to choose a data structure to log those numbers, to store those numbers in a way and taking advantage of the pattern, and hash map is very suitable for this task. And now I'm going to show you what I wrote before, and it was time limit extended, so it passed the time limit. So my algorithm, I did something like I just create a current I and current j, and then I go through those. As you can see, I first so I go through those numbers, and from those numbers I start check if the next number exists. If the next number doesn't exist, then we'll continue the process, as you can see. So I check if the next number exists. If it doesn't exist, I will just continue, and I did two for loop because I have to check both this and this line, both this line and this column. And there's one thing that I have to consider is that it's not in this example, but what if there are numbers like 2, 3, 4? If there are more numbers and the last line of the numbers are not that sorry, so the last row of this array I'm given, so the length of the last row are not the longest. So in that case, I will miss some number because I can get 415, but I cannot get this 16 because there's no number in my last line. So therefore, to solve this question, so what I did is I append some special numbers, so a special character into my last row to make it long enough. Then I remove all those special characters in the end in my result array. But that took too long, because to use the hash map and use the pattern, I only need to go through this array once. Therefore, it's O n. But therefore, the time complexity is O n. But if I use this method, I have to go through this, so I have to constantly checking all the numbers, and so the time complexity is not ideal, I would say. Yeah, therefore choosing the right data structure and the right strategy to solve a algorithm question is very important.